In this video, I want to talk a little bit about stimuli for hormones and the different stimulus or stimuli can fall into three basic categories. We can have hormonal stimuli, we can have neural stimuli, or this somewhat strange category called humoral stimuli. Don't confuse humoral with hormonal. Now, we've already seen some examples of hormonal stimuli. And one of the key examples we've seen is when the hypothalamus talks to that anterior pituitary, And the hormones produced by that hypothalamus are going to stimulate the release of hormones from that anterior pituitary. This would be a hormonal stimuli. For example, when growth hormone, releasing hormone, or somatotropin, that's another name for growth hormone, releasing hormone, binds to a cell in that anterior pituitary, causing that cell to release a hormone of its own. There's many other examples throughout the body. They don't necessarily have to be part of this hypothalamic pituitary axis. They could also be, for example, TRH. TRH would be the hypothalamic hormone that releases the anterior pituitary hormone. TSH, thyroid stimulating hormone. Now, thyroid stimulating hormone is going to be released, and it's going to go affect cells of that thyroid gland. And when it binds to cells of the thyroid gland, follicular cells, it's going to cause those follicular cells to release thyroid hormone, T3 or T4. These are examples of hormonal stimuli. Now, neural stimuli, like the name suggests, is going to involve the nervous system. We've seen how the nervous system can cause the cells of the paraventricular nucleus to send their axons or an action potential down the axon to the axon terminals in the posterior pituitary to release oxytocin. Okay, so this is an example of neural stimuli. We have an afferent neuron, some kind of sensory receptor, in either the breast tissue or the uterus that comes up to the hypothalamus and synapses on cells of the hypothalamus, causing those cells, the really cells of the paraventricular nucleus, to initiate an action potential that's going to release oxytocin from this posterior pituitary. It was the stretching or the nervous system synapsing on that cell that caused the release. There's several other examples of neural stimuli. For example, pain receptors. When pain receptors sense pain, they come in and they synapse on cells of the supraoptic nucleus. And cells of the supraoptic nucleus are going to release antidiuretic hormone. A little different looking hormone than oxytocin. It's going to release antidiuretic hormone in big quantities. And when we have larger quantities, we can even bind to the low affinity receptors in smooth muscle of a blood vessel and get this smooth muscle to contract. That's the namesake for vasopressin, another name for antidiuretic hormone. This is all neural stimuli. Now, humoral stimuli is the harder one to understand. And you got to loosen your shoulders a little bit and understand the origins of this word. This kind of harks back to the days of alchemy, to days of the homunculus, to days of trying to create gold by chemical reactions, or what later became known as brass, basically mixing zinc and copper together, and then selling it as if it were gold. Pseudoscience, this idea that there were body humors like bile that flowed throughout the body and gave people a certain affect or demeanor. Humoral stimuli, just like those things back in that time, we can't really identify with the unaided eye. And not that we can see action potentials or see hormones, but these are more conceptual things. Things like concentrations or pressures or osmolarity. These entities that aren't so easily identifiable, but can have an effect on the release of a hormone. So, for example, antidiuretic hormones released from the posterior pituitary, not only in response to pain, but also in response to low blood pressure or low blood volume. Here's my posterior pituitary gland, and I have cells up in the hypothalamus of the supraoptic nuclei that are going to release antidiuretic hormone to go affect the kidney tubules when it's in low concentration and high concentration. But what's going to stimulate that release is actually low blood pressure. And low pressures aren't something that they're not a tangible object. They're more an idea of less collisions with the wall of a container. Now, truth be told, it's because of baroreceptors in the arch of the aorta or the carotid bodies. And these sensory receptors, these baroreceptors or pressure receptors, are going to send up a afferent neuron to synapse on the cells of the supraoptic nuclei. Now, should we call that neural or should we call that humoral? I'm not a huge fan of these categories because it's kind of a matter of opinion. And what I want students to know, I want them to know the exact stimulus. And then other people can categorize it in different ways, and you can understand their perspective based on that. So it's low blood pressure sensed by these neurons that cause the release of antidiuretic hormone that affects the distal convoluted, or the collecting ducts of the kidneys, to resorb more water and get our blood pressure and blood volume up. Now, another example of this might be insulin. Insulin is released by beta cells in the pancreas in response to low blood glucose. Now, these pancreatic islet cells, these beta cells, can sense glucose concentrations and release their insulin to be taken up into the bloodstream. Taken up by the bloodstream. Now, this isn't neural. It could be hormonal because hormones are long-distance signaling molecules that travel in the blood, and this glucose did at one time travel in the blood. But we tend to classify it more as humoral stimuli. This entity we can't really put our finger on. Blood glucose concentrations. And when blood glucose concentrations rise, blood glucose rise above 70 milligrams per deciliter, we're going to release some insulin in response to that. So that would be a per deciliter, DL, deciliter. This would be an example of humoral stimuli. So I challenge you to think about the father in the waiting room hearing his baby cry for the first time and releasing a little bit of oxytocin, this pair bonding molecule that helps the mother and father become attached to their new baby. Now, these hormones can rise even in the father out in the hallway. They're definitely rising in the mother. That's more because of stretch, but also for other factors. But for the father, he's not experiencing that stretch. Is that hormonal stimuli, neural, or humoral? And if somebody said, well, that's humoral stimuli, that's something that we can't quite pin down. We can't see the effect of crying and the implications that crying has to make the father become more attached to the baby. Or another person might say, well, that's neural stimuli. Sensory receptors perceive those waves striking the ear, and then those pitched noise of a baby crying synapse on cells of the supraoptic nuclei, paraventricular nucleus, causing a release of oxytocin. If somebody called it neural, you would understand their perspective. If somebody called it humoral, you would understand their perspective. Those are the ideas of different types of stimuli. Again, I don't love these categories, but they're something you should be familiar with when you hear people using them. You can understand the perspective that they're coming from.